Hi everyone, this is a video tutorial to help you figure out how to assign priority when you're trying to determine the RS or EZ configuration of a structure. So over here we have our asymmetric center. That's a carbon that's sp3 hybridized with 4 different groups attached. In this case, we're going to be dealing with the RS configuration. So the first thing you have to do is assign the priorities. So now when you're assigning priorities, remember you're going to take it one atom at a time, meaning you're only going to start with the atom that is immediately attached to that asymmetric center. So in this case, you'd be comparing carbon to carbon to carbon and carbon. Now obviously at this point you can't really tell much because everything is a carbon. So in a case where you have the same atom repeating itself, you're going to look at the next atoms that are adjacent to that place. Meaning over here this carbon has an oxygen and a hydrogen adjacent to it. Now the thing is, this carbon is double bonded to that oxygen. So this will count as 2 CO bonds, and it also has 1 CH bond. So I'm not looking at the bonds that they all have in common, I'm looking at the bonds that they would have in difference to each other. So here 2 CO bonds because of the double, 1 CH bond because of this here. Now look at this carbon. So this carbon here would have 2 CH bonds, and it would also have 1 CO bond. Now I move to this carbon. This carbon would also have 2 CH bonds, the 2 H's attached to that C, and it would also be attached to this carbon, so it has 1 CC bond. Lastly, I look at this one. This one would just have 3 CH bonds attached to it. Now I'm going to compare here and see if I can tell the difference. What would have the highest priority? So now in this case here, this would have 2 CO bonds. O has the highest atomic number, so that one is going to take priority. And because there are 2 of them, that would trump only having 1 of them, meaning that this group here would have the highest priority. Now if I take a look at this group versus this group, this has 2 CH's, that matches. This has a CO, this has a CC. Once again, the O is going to have a higher priority, so this would be group number 2. And now if I compare these two, this has 3 CH's, 2 CH's, and 1 CC. This C would have priority, so this would be group 3, and this one here would be group 4. So that's how you would rank priority for a situation like this. Let's take a look at one more example. Okay, so just to hit this home, let's try this one more time on another compound. So remember, we're ranking priority and we're doing it based on the atomic number. The higher the atomic number, the higher the priority. So if I take a look at this, the first thing we do is look at the atoms that are immediately attached. So I've got a carbon, a carbon, a carbon, and a bromine. So the only thing I can tell and distinguish between is the bromine obviously is different from the 3 carbons. And the bromine has a higher atomic number, so we know that bromine would be ranked number 1. So now when I'm in this case where I've got 3 carbons, I have to then look at what's attached to those carbons. So I'm going to spread out a little bit. So if I take a look at this carbon would have 2 CH bonds right here, and it would have 1 CC bond. This carbon here would also have 2 CH bonds, and it would also have 1 CC bond. Lastly, I look at this one, and this carbon here is going to have 3 CC bonds. So that triple, you're going to count 3 times, so you're going to pretend as though there were 3 carbon-to-carbon bonds. So we have 3 CC, and then these 2 are identical. So now, I can't distinguish between those because the attachments are the same, but this one I can because they're different. So if I look at this would have a higher priority than those because a carbon has a higher atomic number than the hydrogens do, which would mean that this here would have to be group 2. So remember, it has nothing to do with the size, it has to do with what is attached in the next spot. So now at this point, I'm going to be moving on, and I'm going to look at this carbon and figure out, okay, what are the attachments that that carbon has? Because now I'm moving out even further. So I've handled this one, now I'm looking at this. There's a triple bond to an N, so this would count for 3 CN bonds. Now I'm looking at this carbon here and its attachments. This one would have 3 CC bonds. So now I finally have a difference between those 2 groups. So now I'm going to compare the C and the N. N is going to have a higher atomic number than carbon, so this one here would be ranked group 3, and this one here would be ranked group 4. So hopefully you can take those ideas and utilize them when you're figuring out the priorities for different compounds when you're figuring out your configurations.